Let's go. Good afternoon, everyone. I'm Jeremy Picot-Clement, Photonics Technology Manager at EPIC. I'm really pleased to be here and welcome you for this EPIC members new product release. And before to start, I would like just to introduce you EPIC. So what is EPIC? EPIC is the largest photonics industry association with more than 800 members working in the photonics field. Here is the EPIC team made on 10 people all passionate by photonics, and we try to act as a catalyzer for the photonics industry by maintaining a strong network interaction between our members, by organizing physical and online events, publishing markets and technology reports, organizing technical workshops, and with a lot of other activities you could find on our website. Here is the event and marketing management team, and here is the technology management team. And I'm a part of this team, of course. And I wanted to show you a few of our next physical events for the next few months. So we'll be at Photonics West in January, where we will organize several events. We'll have the EPIC Annual General Meeting in Helsinki, Finland, in March 2023. We have an EPIC technology meeting at HBK about fiber sensing in Porto, Portugal, and we have also in May 2023 an event related to AR/VR at Jabil Optics in Germany. We organize online technology meeting as well. So every 2 weeks, so we have something about Earth observation at the end of November, something about photonics for food and beverages in December, metamaterials in January, microLED in the next year. So I invite you, if you're interested, to have a look on our website, and if you want to participate or to be a speaker, we just have to send us an email, and we'll see if we can do this. Here is a panelist of today. So thank you very much to our speakers. We'll start with Claudia Dippold, Product Manager at Instrument System, followed by McKee, CTO at Sivers Photonics. We'll have Ksenija Varga, Business Development Manager at EVG Group, Francois Couny, Solution Manager at EXFO, and we'll finish with Robert Kirchner, the CEO at HETEROMERGE. So thank you very much for attend, and thanks a lot to our speakers. And we'll start now with Claudia Dippold, Product Manager at Instrument System, with the first presentation. So Claudia, I stopped sharing, and you can start your presentation.
Thank you, Jeremy. So here it comes. Thank you, everybody, for joining my really short presentation about our new CAS 140D infrared spectrometer. It's a high resolution spectrometer, but before I get into the details, I just want to show you some of the applications behind, which can be found both in mobile devices like flood illumination, in cell phones like AR, VR, eye tracking, but also automotive applications, LiDAR applications, for example, or medical stuff like blood glucose measurements or body hydration. Instrument Sense Systems not only builds these measurement instruments, the spectrometers, also camera systems, but one of our core competencies is also the calibration of these instruments. So all our instruments are absolutely calibrated, and they are traceably calibrated, traceable towards a standard given by a national institute, like in Germany, the PTB, for example, or the NIST Institute. Not only do we calibrate our instruments, but also we do an outgoing quality control with standard audit sources. We are manufacturing ourselves and calibrating as well. And we do sell these audit sources also to our customers. So also the customer during the production process in the fab can ensure traceability and maintaining the error budget. Our labs here in Germany and also a mirror lab in Shanghai is accredited to ISO 7025. And we do have a large service network in Asia in order to be in direct and close contact also locally with manufacturers there. So about these audit sources, something a little closer. These need to resemble the DUT of the customer as close as possible. So for infrared, we're not only having one, we're having 6 different wavelengths in order to really match the wavelength of the customer DUT. These are highly stable infrared sources based on LEDs. They are burned in, so they have a stable light output, which is stored in the ACS, which the customer can then use to monitor the stability of the measuring instrument, of the spectrometer. And of course, only with, you also need insured driving current with it. This is provided by the ACU power unit, also manufactured by ES. And now finally, let's come to the spectrometer itself. It's a new high precision instrument with an InGaAs sensor, 512 pixels resolution, resulting in 9 nanometer resolution with good high sensitivity, low noise and dark current. It's terminally stabilized to -10 degrees, ensuring this dark current, and it has really fast electronics for fast readouts, which results in also increased productivity and throughput. Compared to the predecessor, the CAS 140 CT, we have improved the spectrograph design to have less optical artifacts like less inner reflections and increased repeatability. So if you look on the bottom right, you can see a small comparison of the integration times where the predecessor, the 140 CT, was at 10 milliseconds minimum. We are now at a 1 millisecond minimum integration time. The CAS 140D series also has automatic accessory recognition. So if you connect, for example, an integrating sphere or some incoupling optics, it will automatically detect what is connected there and will load the correct calibration file, which belongs to this optic, which is stored in the CAS and then automatically retrieved. It comes with an 8-position filter wheel, which can be equipped with OD filters in order to adjust the customer's need regarded to the DOT powers they want to measure. And of course, it's highly robust with a good shelter against dust, especially in the optical path. You need a good dust detection. And it has a 3-color status bar to indicate when the device is ready for measurement after warm-up. Here you can see a direct comparison between regarding sensitivity of the predecessor and the CAS 140D. It's the same device, same settings, and you see that the green line has a higher throughput than the red one with the predecessor. And also stray light, where we used a bandpass filter, high pass filter here. You can see the reduced light throughput in this region compared to the predecessor as well. So let's come to the summary. I just summarize not only instrument systems provides the spectrometers and instruments, but also the calibration and the audit sources for maintaining this calibration. We are ISO 70025 accredited lab, and the customers, of course, get really close support if it comes to integration of our products in their production lines. Thank you very much for the attention.
Thank you very much, Claudia.
And I hope it was in time.
Yeah, you're on time. Don't worry. So, do we have any question for Claudia, please? You can raise your hand through Zoom. At the bottom, you have a button. So maybe I have a question for you, Claudia.
Yeah, sure.
What are the main markets you are targeting with this kind of product?
The main market is for sure the mobile devices market, I would say. Okay,
so you are able to put this product on a production line, for example, or it's
yes.
Yeah,
we are mainly implementing these products in production lines. They often go together even with cameras. So maybe not in the infrared region, but for the visible spectrometers, we often use them together with cameras, or even together with microscope optical cameras like our VTC 4000, which is a device which can microscopically measure VCSEL devices in the infrared region.
Okay, okay, good. Okay, so if we have no other question, thank you again, Claudia, for your presentation. Thanks again, and we can start with our next speaker, next product release, Andrew McKee, CTO at Sivers Photonics. So Andrew, you can share your presentation and start. The floor is yours.
Okay, can you see that okay?
Yeah, you can start.
Okay, thanks. It's nice to have this opportunity to talk about the capabilities that we have here at Sivers Photonics. I'll give some sort of general introduction about what we do as a business, and then focus on some of the new products that we've announced at the start of this year, and also much more recently. Okay, so we are a UK-based business. We both design and manufacture here in Scotland on the outskirts of Glasgow. We are a relatively well-established company. We've been operating for more than 20 years, designing and manufacturing 3.5 photonic devices. Formerly, we were known as CST Global. 2 years ago, we rebranded as Sivers Photonics. So here in the UK, we have a very nice 100mm wafer fab with a capacity of up to 5,000 wafer starts per year. And that's a class 50 clean room facility. So we really offer to our customers a complete end-to-end chip solution from design right through to volume manufacture. So we can engage with customers who come to us with just a chip specification. They don't necessarily know how to make that chip, but we can offer both the design and manufacturing services on site here. Obviously, we're ISO certified. We have about 85 members of staff today and growing rapidly. Today, most of our business is in the west coast of the US. We supply to many of the Fortune 100 companies and many Silicon Valley startup customers also. So what is our real technology expertise? So we offer this sort of design and manufacturing services, as I said, for a very broad range of photonic devices. That includes things like Fabry-Perot lasers, DFB lasers, semiconductor optical amplifiers, reflective SOAs, and we also make photodetectors also in the fab. But I would say our core expertise is very much on the laser side. So we view ourselves as one of the sort of key players in the whole silicon photonics ecosystem, supplying the 3.5 indium phosphide devices that really light up, illuminate these silicon photonic circuits. So we manufacture our devices on our IMP100 platform, and we have sort of multiple commercial users already on that platform. Throughout the history of the business, we've scaled up over time to be a volume supplier of laser chips, and we're capable of shipping over 1 million lasers per month from the facility, and we have in excess of 45 million lasers out in the field today. And we supply devices into a broad range of markets, but primarily I would say it's into data comms and the sensing markets, some of which Claudia just spoke about. So what do our lasers actually look like? So we have some very specific features on our devices which really make them optimized for silicon photonic hybrid integration. What are those features? So we have very accurate vertical alignment surfaces on the devices which make Z alignment into the silicon photonic circuits very easy. We're using etch facets on our lasers. Those are self-aligned with the ridges and also the facets themselves. So we can do very accurate XY alignment of these devices, which is really critical to get high coupling efficiency from our laser chips into the silicon photonic waveguides. We also have metal pads optimized for flip chip bonding, and also we put gold tin solder down onto devices, which many of our customers really appreciate. It means they don't have to put gold tin down onto the silicon wafers. And of course, we have sort of backside alignment fiducial marks on the devices. Now, typically, what we ship to our customers is actually devices in array format, so maybe a 4x or 8x array, and that's obviously coupled into multiple silicon nitride input waveguides on the silicon photonic side. In our devices, our laser sources are being integrated into all of the commercial silicon photonic platforms, such as GlobalFoundries, Tower Semiconductor, IMEC, AMF, etc. So this slide goes into a little bit more detail about our collaboration with IMEC and a company, ASM Hemicra, who build very high precision die bond tools. So what we have here is very high accuracy placement of our laser chips onto the IMEC silicon photonic platform, below 0.5 micron die placement accuracy. So it's extremely accurate alignment that's now capable by these tools. And that's really critical to achieve very high coupling efficiency between the laser and the waveguide. And that, of course, is important for power budget requirements. And we're typically achieving about 1.5 dB coupling efficiency between the laser and the silicon nitride waveguides. And you can see just some schematics of really what's happening here and the way our chips are actually bonded onto the silicon photonic circuits. Okay, onto some of the more product-focused slides that we have. So we make these custom DFB laser arrays for silicon photonic applications. What do they look like? We show them here on this slide. So what we're making here is a laser chip with 8 individually addressable lasers. So each laser is emitting more than 50 milliwatts of CW optical output power, and each laser is at a different frequency, a different color, ranging around the sort of 1300 nanometer wavelength range, spaced by 400 gigahertz. So all of this technology is based on the CW WDM MSA. It's a consortium of many of the sort of datacom companies and chip suppliers. We're trying to standardize the technology and the chip solutions in this space. And we're very much at the forefront of delivering products into this area. So we announced this sort of product family back at OFC in March of this year. Since then, we've been working extensively with a company called Ayar Labs. Ayar Labs are one of the most exciting sort of startups in Silicon Valley, doing ultra high speed optical interconnect technology, basically displacing copper in things like data centers and other high data capacity applications. So working with those guys, we've got our devices, our arrays going into their supernova optical modules. And we actually had a live demo at the ECOC show back in September in Basel. So that was very exciting for us and a great endorsement of our sort of technology. But primarily what we're doing here is selling custom versions of these devices to our customers today. We also announced recently we have a 32x version of this same device. You can see an image of the device at the top. So we've got 32 individually addressable lasers on a single piece of indium phosphide, all functional. So we've got 100 gigahertz channel spacing. That's about 0.6 nanometer, again, centered around 1300. This opens up the opportunity to do very, very high capacity optical interconnect links using these devices. So we can see full functionality. All the devices are fully functional, working, meeting the spec. And we also have excellent power uniformity across the array. So emitting in excess of 2 watts of optical power at about 30% wall plug efficiency from these devices. So a very exciting technology for us and capability of our demonstration. So just in summary, we at Sivers Photonics have complete in-house design for 3.5 chip design, fab, test, qual, and volume manufacture. Our indium phosphide platform provides advanced customized 3.5 devices for silicon photonic hybrid integration. And today we form a vital part of the silicon photonic ecosystem and are a key supplier to many Fortune 100 companies, Silicon Valley startups. Thank you for your time today.
Thank you very much, Andrew, for your presentation, very interesting product. So do we have any question from the participants? Please, you can raise your hand through Zoom. Yeah, we'll start with one question, Andrew. You talked about volume. What are the volume you are able to provide today? Huge volume for?
Yeah, so we have traditionally shipped about 1 million lasers per month from the facility, but that was into the sort of pawn market, which was a very sort of Asian-based market. That's been completely consumed by local suppliers in China. So we do almost zero business now in Asia because the local competition is taking sort of price points so low. It's impossible to compete out there. For the 8x arrays that we've showed previously, we anticipate we've got the capacity to produce somewhere in the region of a few million arrays per year from the facility we have in existence today. and that's going to have a selling price of a few $100s per array. So pretty significant revenue capability with the existing facility that we have here today in the UK.
Okay, yeah, interesting. And today you are mainly looking for optical source providers, for example, to integrate your technology in their system.
Yeah, we're looking for, we deal with customers who are wanting to add something to, transceiver architecture, to novel module design architecture, and we supply the custom 3.5 chips into those applications.
Mm-hmm. Okay.
And there's many large companies that really want to invest right down to sort of custom chip level. That's particularly true in things like the LiDAR space.
Yeah.
People have to differentiate the technology. There's so many LiDAR companies out there. They have to do something novel, and to do that, I go right down to the sort of silicon photonics circuit, the 3.5 laser chip, to do something unique in that space. So we find lots of business dealing with sort of startups in that particular area.
Yeah, really good, impressive.
But there's also lots of applications in biometric sensing.
Yeah, sure.
People are trying to add additional functionality to mobile devices, of course, and they need laser technology or optical light source technology to allow that to happen. So there's many opportunities for technology.
Yeah. So no more question from participants. Okay. Thank you again, Andrew, for your presentation. Thanks a lot.
Thanks.
Really interesting. So now we can move forward with Ksenija Varga, Business Development Manager at EBG Group. So Ksenija, we can start. The floor is yours.
Okay, thank you. So first of all, thank you to the EPIC team to give me this opportunity to present EBG and the product we launched just recently. And yeah, hello to everybody in the Zoom room and also on the YouTube video watching us. So the title of my today's presentation is the lithoscale tool. It's exposure tool designed for the next generation devices we are presenting in advanced packaging and also in MEMS. For the beginning, I have 6 slides. Please interrupt me if I speak too much, so I would like to be on time. First of all, just one general slide about the company. We are a family-owned company. The owners founded the company 40 years ago. We are based in very nice city in Upper Austria, actually close to German border. We have, so here is the headquarters. We have 1,100 people altogether. And we have, besides the headquarters in Austria, we have subsidiaries in China, in Taiwan, in Japan, in Korea, and USA, so that we can serve the customer on the global level. We have bonding equipment. So this is the strongest, let's say, business unit or the strongest business in our portfolio. Then we have a nanoimprint technology or lithography tools, and we have also optical lithography tools, and also the newest product we launched is this maskless lithography tool, and I will be speaking more about this technology. So about this maskless exposure lithography tool. So how do we write the patterns? We have a laser source. We operate in 2 different wavelengths. This is important so that we can pattern with 2 different wavelengths. We can pattern really very broad types of the resist, like thin, thick resist, dielectrics, buffer layer codes, also colored resist. And what is very special, let's say, in comparison maybe to other products on the market, that we can really downscale, actually below 2 microns. The newest tool, which we will, let's say, launching, or the next generation of the tool, we will be able to scale down to almost to 1.5 microns, actually, because we are targeting the back end of line technologies or lithography, and this is actually the resolution we are working with. Okay, so the maskless exposure tool, let's say the brand name of this exposure technology is a lithoscale. So we can process very broad range of the wafers for the small 100 millimeters to 300 millimeter wafers. It's digital lithography. Also, we call it. We do not have a, let's say, mask as in mask aligner or reticle as in the stepper technology. we have the real-time data transfer. So our mask is, let's say, digital file. How do we call it? We can have, so the technology is very versatile. It means we can write every possible pattern, what we can imagine on the real time, independent on the, let's say, complexity of the layout. Yeah, we can also, when it comes to the sizes or to the substrate scales, we can process also until panel size. This is what our technology is capable for. We have different configurations of the two, from the small scales, and we are scaling up from different configurations depending on the customer needs. Okay, so now I would like to show you our target application of this technology. So we are very well established in advanced packaging, fan-out, wafer-level fan-out, fan-in packaging. We are really good established on the global level in the MEMS technology, and also biomedical and let's say, medical electronics. Certain, let's say, applications are using this lithoscale technology. What we are building now, and maybe we can have an opportunity to discuss about, let's say, new projects or new leads. We are focusing, or we are positioning ourselves in the new packaging, let's say, technologies like 5G or 6G, because, for example, like antenna in package, they need to have also special, let's say, packaging construction where our technology can be useful. Then this high performance computing, then the 3D sensing. And also, last but not at least, one of the segments we are focusing on is high density IC substrates. Okay, now the last two slides, I would like to show you the ASM and also optical microscopy images of these patterns. Here on the upper part of the presentation, we see two patterns which are, let's say, typical for the MEMS industry. What is important that when it comes to lithography, we have high aspect ratio of the resists or the polymers. We have extreme topography, so we have high depth of focus and broad variety of the design. That's why the producers of the MEMS, let's say, like to have our product in comparison to, let's say, stepper or mask aligner, because they can, let's say, change the design very easily and also produce, let's say, different patterns or different designs. And what is also special about this technology is that there is a short, let's say, cycle from R&D to HVM internally within the company, or let's say it's shorter cycle or time to market for the specific designs. Also, when it comes to photonics, the special development was we took the, let's say, black resist also for MEMS or for photonic devices, and it was also possible to pattern it on the litho scale. We can pattern, of course, thin, thick resist, different, let's say, aspect ratio and different topographies. This is when it comes to the MEMS application. When it comes to advanced packaging application, the very special thing about our tool is that when you have the packaging, then you have kind of could happen, let's say, distortion or irregularities of the substrate. And with this tool, we have in real time compensation distortion. And then that's why it's so suitable for advanced packaging. So we have got already external references to use this so for fan-out wafer level packaging. We can also say that we identify, let's say, or we evaluated broad range of the electrics for advanced packaging application on this technology. Actually, now with this couple of slides, I come to the end of my presentation. I did not have a look on the time. I hope I was within my 6 minutes. And yeah, thank you for listening. And I'm open to have your questions. This is my email address. And please contact me if you see the potential for collaboration. Thank you,
Ksenija. Thank you very much. You're on time. Don't worry. That's Good. Perfect.
So I need to click on stop share, or should I keep the presentation?
No, like this. It's okay for now. Let's see if we have some questions. Yes, from Imagine Optics, please.
Hello.
Yeah. Hello.
Hello, thank you for your presentation. I would like to ask you, because you just showed microscopy, like topographic, let's say, presentation of your, let's say, patterns, but what other metrology, like opportunities you're using to testify your patterns for like crackings and etc.? Do you use some interferometry, wavefront sensing, or any other kind of testing?
Mm-hmm. So what we are internally having, if we use, we measure the thickness, then we can define, let's say, the resolution. We have AFM as well, ACM, optical microscopy level. So, but when it comes, for example, to testing, let's say, adhesion, polymer on the wafer, then we do not have this, let's say, opportunity. Or here, then we need external customers or partners or supplier to test this for us. Like mechanical behavior, we do not have this, or for example, thermal behavior of the coated substrates, this we cannot use this here. But they are good, for example, like Fraunhofer, they have a lot of possibilities to do then the characterization of the patterned dielectrics.
Yes, they do have specific benches. Yes, they do.
Yeah. Actually, you can have a look on the internet site. I'm not so familiar with this, let's say, business unit. We have also like a metrology part, and we can email address, and then I can
yes, that would be amazing, because
presentation more about metrology capability.
Okay, thank you so much.
Yeah, because can you just introduce us what you are doing at Imagine Optics?
So hello, my name is Alvita. I'm a sales engineer at Imagine Optics. So that's why I was asking you about metrology, because we are producing wavefront metrology opportunities, including Shack-Hartmann wavefront sensors. So that's why I was interested on how are you measuring actually the quality of your patterns, of your, let's say, printed patterns.
Yeah, good.
Thank you.
Thank you very much for your question. And if we have no other question, I would like to thank you again, Ksenija. And yeah, if you want to be in touch with Ksenija, you can directly send her an email, or you can also ask us at EPIC. We can put you in contact with her.
Okay, thanks.
Thank you very much. And now we can welcome our next speaker, Francois Couny, Solution Manager at EXFO. So Francois, you can share your screen and start your presentation.
Okay, I hope you can all see my screen.
Yes.
Yeah, good. So I'm Francois Couny from EXFO. Actually, it's experts in fiber optics. So we're a test and measurement company for anything to do with fiber optics, portable, but also in R&D and development of new optical components. I would say not limited to telecoms, but mostly within the telecoms wavelength range. And today, it's my pleasure to introduce a new product family of tunable lasers. So tunable lasers are at the heart of most of our systems for testing optical components, providing the wavelengths variation, and we interrogate the spectrum of the component, and reconstruct basically this information, this response of the device with this type of lasers. So what we are looking for in this type of equipment is obviously a broad wavelengths coverage, and we have with the T200S and the T500S here some tunability within the O band or the CL band, so around 1310 or 1550 nanometers. But with the T500S, we go even further and we cover the in-between bands, so the O band or the CL band, but also the bands around 1400 or 1500, or even all the way up to 1680 nanometers. You're looking also for a laser with high power, typically 10 dBm. but even much higher than that, 15 or so. You're also looking for a laser if you want to interrogate correctly your component, a laser that has a low noise and a usable signal that is quite high. So here we're referencing the signal to source spontaneous emission ratio, SSSER, and needs to be as low as possible. And also we need to be able to scan or to perform a sweep of the wavelengths on these devices as quickly as possible. Here with these new lasers, we introduced at 200 nanometers per second. Previous line of lasers that we had that was at 100 nanometers per second scan. And during that sweep, during that movement of the wavelengths, you also want to avoid mod hops. So you want to have a continuous, smooth variation of the wavelengths as you do so. So going into more details about the two lines of products, the T200S CL and T200S O band. So cover as the name implies, the O band or the CL band. So you can see at the bottom here, there's a wavelength range that is covered with an optical power output of 10 dBm. And with a sweep speed of 200 nanometers per second scan. So during that sweep speed, which basically would only take a half a second or so over this range, you can then collect some data, some acquisition about the component that you're testing. This is made possible with the two component testing products that we have at EXFO, the CTP10 and the CT440, which are the two products that collect the data and display the spectrum automatically on the screen using such tunable lasers. What is also interesting with this laser is that it can be used as a fixed wavelength or go-to wavelength within the range of the wavelength that's possible to cover, with a line width that is below 50 kilohertz and with an accuracy of plus or minus 5 picometers. So this is a very good go-to wavelength laser with that is actually very narrow in terms of line width. So it could be useful both for an application where you want to go to a wavelength, perform a measurement, an alignment of some kind, and then perform a sweep within the same wavelength range. So for peak application, photonic integrated circuit application, for example, this is quite interesting to align first at a fixed wavelength and then perform the scan. Going further with the T500S, so this covers a much broader wavelength range through different models that are listed below, with three models: the O band, the ES band, and the CLU band. We can cover with three lasers from 1240 nanometers to 1680 nanometers, with an adjustable optical power that is 10 dBm, but above, with a peak of 14 dBm. And here the strength of this laser is also the fact that it is usable in both directions of the sweep. So you can sweep from low wavelengths to high wavelengths. And when you come back to the low wavelengths, it is also calibrated and functional so that it can be used or will be able to use it with the CTP10, once again, the component testing platform from EXFO. This is an upcoming function, but we're developing right now this functionality so that you can gain in terms of speed, and speed we know is essential for photonic integrated circuits. So positioning these two new tunable lasers, continuously tunable lasers within the range of the EXFO's portfolio of tunables, we have the micro ITLAs starting at the bottom here. So they are mostly a go-to laser, and you fix the wavelengths and you kind of leave it there in the C or the L band through two products. So stepped tunable laser through the T100 that is available, as you can see, in a mainframe that's called the O6 platform. Here we have several wavelength range that are covered, and each of them are stepped tunable, which means that they're not usable when they change the wavelengths. To be able to do that, you need a continuously tunable laser. And this is where these two lines of two families of products, the T200S, the T500S, come into play. And we can clearly see here for the T500S, the O band, the S-band and CLU band with some overlap in between all of them. With 3 lasers, we can cover the full wavelength range. So that could be interesting. Once again, coming back to a spectral characterization, where you sweep the laser or the lasers as a function of wavelengths, and with the CTP10, which you can see here in the middle, you can collect this information regarding wavelengths, the information on the power through the bank of detectors that are inside this instrument. And then you can recreate the actual performance or the spectrum of the filters, the ring resonators, the AWGs that you are actually measuring. You do that with picometer resolution at speed, 200 nanometers per second bidirectional. And you can even have further measurements such as polarization dependent loss. You can test up to 100 outputs from one single device. And obviously here I'm talking about telecoms wavelength range, spectral testing. So once again, within the range of each of the laser or lasers if they are combined together. So here today we've introduced the swept tunable lasers. They're part of a larger portfolio of products when we talk about peak testing or photonic integrated testing. It being a simple laser and detector on the left-hand side, matrix switch, an optical spectrum analyzer also with the OCA20 that can be useful to test lasers or WDM signals. And to the right-hand side also, it's interesting sometimes to go further with the testing of such components and test the traffic analysis. This is more for transceivers and mainly telecoms applications, but this is something that is possible within the portfolio of EXFO. So on that note, I will end. And if you want more information, just type in within the EXFO website, a tunable laser or lasers. And then you'll have more information about the family of products and these 2 products in particular that we've launched today. Thank you very much.
Thank you very much, Francois, for your presentation. Very interesting. So do we have any question from the participants? Because we understood well that your product is really adapted for peaks testing. But do you have in mind other markets which could be really interesting for this product? Yeah.
So, I mean, the laser on its own it's been used. The predecessor of this product has been used in the lab as a workhouse. Any photonics lab need at one point some tunable laser to go to a particular wavelength or sweep a particular wavelength. So particularly this type of lasers are very good because they are very pure in terms of the spectrum, the spectral quality. They have the signal and they have very low noise, what I call the SSSER. This is very important in some applications where you really want to interrogate one particular wavelength and none of the other wavelengths that would be within the noise. That's one of other applications in R&D, basically R&D universities type of applications.
Sure. Thank you. Okay, so if you have no question, thank you very much again.
Thank you very much.
Thanks a lot. And last but not least, so Robert Kirchner, CEO of HETEROMERGE, will give its presentation. Robert, you can share your screen and start the presentation. You are muted. Yeah.
Yes, thank you everyone for staying that late and for staying here that late and being with us and for enabling us to present our product launch today, which is actually a pilot product and a pilot customer program. And what we are dealing with and what our product is a multi-material printhead for high resolution 3D printing of, for example, optics. So, but let me start with an analogy that if you look at desktop printing, color printing has replaced black and white printing for the very simple reason of if you want to get a decent function, so might it be a nice picture or want to transfer information, you will want to use color instead of black and white. And the same is true for 3D printing. So if you want to have function printed, you need a printhead that can deal with multiple materials. And unfortunately, so far in the very high resolution 3D printing, two-photon multi-photon printing, this color printing is not existing. And as HETEROMERGE is a spin-off project of the Technical University in Dresden, we are solving this issue by our printhead, and I will tell you more about the details in the upcoming slides. So, but maybe first, who are we? We are a team, like quite interdisciplinary team of engineers, physicists, designers, software developers, process engineers, and we bring all together this expertise to solve this problem of multi-material printing. Now, I mentioned small, and for those of you that are not familiar with this multi-photon lithography tool or two-photon lithography printing, just let me show this example how small this can be printed and the precision that can be achieved with it. So it's a small castle on top of a pencil tip here. You won't even see, of course, not with your bare eye, but even with a decent microscope, you will have challenges to see these very fine details below 1 micrometer in resolution. So this technology cannot print multiple colors, but just imagine that you would have a printhead that can deal with multiple materials, or we say multiple colors. What would be possible beyond that? We would have a high resolution multicolor printing. So we see it on two sides. So this is compound optics on one side and photonics on the other side, where we think 3D printing has really an edge to be used. So one side is making very compact optics with the fully printed stacks, maybe with aperture, with different materials, to get achromatic, color-corrected optics fully printed, very much miniaturized for airborne applications, for mobile applications, for smart glasses applications. And on the other side, all the data we produce with these devices transferred to the data center, to the very large data centers, where it is unfortunately still to be converted from optical to electrical and processed and converted back, where you want to bring this conversion very close to the optical chip. So you want to print efficient couplers that can be as close as possible to the electronics. And we see really a place here for free-form micro-optics printing that has, of course, the free opportunity to shape the application, the device as you want to have, but also with our printhead now to use multiple materials. So in this example of this about 100 micron lens, you can of course have a mechanical material that gives the stability, but most importantly, two different optical materials that are merged together in this printing process, or that are printed in a single process run. Now we have identified, basically, as mentioned before, two markets with a significant share and significant growth rates at the moment. One is the microimaging optics, and this is just another example of a endoscopy optic, single-use disposable optic printed on top of an optical fiber, not by us, by a group in Stuttgart, but where I can imagine now you have access not only to the free shape of this optic, you have also access to a broad range of materials you can integrate in your design and finally print in a single run. And the other side is what I mentioned, is coupling from the very coarse world of optical fibers into the photonic integrated chips, the PICs we have heard about already during the talks before, where I can create optics on spot and with the free form design opportunities and independent of the technology, where I can really get highly efficient coupling elements between the fiber and the optical chip. Now, this is not only a vision, an idea of a printhead. This printhead indeed is existing, and what you can see here is the printer we have now in our lab, and we are upgrading and using this as printhead 4. What you see is an electronics box in an early version alpha release at the beginning of this year. What you cannot see is what we sometimes refer to as the magic that is happening inside. So if you would look inside, you would see what the white part is here, is the printhead, and it's nothing else than a high precision mechanics system and fluidic system that delivers liquid to the print area and removes excessive material. So what you'll see in a quick movie, if I run it now, you see this colored material with the optical dye for simplicity, but can be also different refractive indices or soft and rigid materials. And on the other side, the second material, and you want to print with two materials. So you inject one material into the print area where the laser is really printing layer by layer, as in classical laser 3D printing. And once you need the new material, you just swap the material and you don't need to move anything, not the optics, not the print substrate. So this is a 10x speed up of the process. So what you see here in 3 and 6 seconds is in real time less than 60 seconds process time. So you see the red dyed material injected. Now you can print, and we immediately swap back to the colorless material, to the dye-less material in less than 60 seconds. So that means you can alternate printing and material swapping processes now that is not possible before. So with that, of course, you can speed up your process significantly. So we think it's, or we know it's a 10x faster than the state-of-the-art classical process, and it's automated. You also save labor and save time. But more interesting for optics printing is, I think, you can achieve almost perfect placement because you're not moving anything, neither again the substrate or the printhead. You just change the environment around the print, and that gives you up to 10x improvement in the accuracy of placement. You can for sure go below 50 nanometer in placement accuracy of the optical axis of lenses you print on top of each other, for example. And you can even approach the 10 nanometer accuracy of the, in our case, the piezo stage that keeps the print stable and aligned during the printing process. Even more interesting for applications, I think, and that's why we are here, is optical applications that have already active devices. So we can print in principle on any device that can be a flat, silicon or glass substrate, but I think it's much more interesting to print on active optic devices, LEDs or VCSELs or lasers, where you can directly integrate the optics, the printed optics, onto the device during the wafer process. So that gives you basically infinite opportunities of application of this multi-material printer technology. So we are here now to launch this pilot product or pilot customer program, and there's the chance to be the first one that works with this product, what we call Merge One. So can be the first one to work with Merge One. And we made a quite, I think, attractive program and surrounding around this program. So you can basically you get the tool for up to 50% of the list price if you're one of the 10 first ones subscribing to this program. You will get along 3 years of R&D support. So that means for the processing, you need the right material parameters, the right process parameters, and we will provide you with these materials parameters for free. You get a 1-year functional upgrade of the system. So if you find after 1 year, we have developed the system further and you want to get the latest upgrade during the time, you can always get the latest upgrade because we're continuing developing this technology. And if you decide after this time that you want to give your prototype back and you want to have the full product, you also get a 50% discount on this product. We will provide you also with 1 year exclusive on-site service with our technicians. You only have to cover the travel costs, depending if it's quite far outside Europe. And at the end of the program, which is going to run roughly 1 year, we have an exclusive scientific pilot customer meeting where you all can come together and share the experience exclusively among this group. So as I meant, the registration is already open. We're closing the application around March, or exactly March next year. We limited to 10 pilot customers at the moment. And I have to tell you, unfortunately, you cannot be the first one, but you can be the second one to work with the system, because our first pilot customer now we have already in Germany, in Stuttgart, at the Force Physics Institute, Professor Harald Gießen, printing stacked optics for endoscopy, for minimal invasive endoscopy. And what he said was quite remarkable during training. He said that for him, this material exchange process is a really new paradigm in the fabrication process. So I think this is the right time to join now. We all know that 3D printing is in industry, and we believe that 2-photon printing enters industry in the next 2 to 5 years, especially because of the photonics push and pull from the industry, and of course also the multi-material opportunity we bring along with our technology now. So thank you very much for being with us, and I'm happy to answer any question you might have to this technology. And also my colleague Jörg here, my business partner, is in the audience and can also answer further questions you might have. So thank you very much.
Thank you very much, Robert, for this presentation. It's really, really impressive. what you're able to propose and what you're able to do. Let's see if we have some questions from participants. I would just ask maybe a few technical questions. Maybe you mentioned it during the presentation, but what is the minimum resolution you are able to reach with this system?
So we have the printhead that goes as an upgrade to the 2-photon systems. So the minimal resolution basically comes from technology itself. So depending on the configuration, but the minimum line width you can get is around 150 to 160 nanometer with a resolution below 400 nanometer.
Okay.
I mean, the thing is, you can print very small optics, but you have no chance to post-process the optics, and it gives you about what you need 10 nanometer arm as minimal roughness of the surface. But now you can have it for multiple materials and not for a single material only.
Yeah, sure. Sure. And speaking about materials, what kind of materials you are able to print? It's all available materials is possible?
It's all polymeric materials, mostly all commercial materials available from low viscous material to higher viscous materials. Of course, the viscosity determines the exchange time. So, but all the commercial materials we have under test, and quite a large range is already used by the pilot customer.
Okay, that's really interesting, and I hope that it will work for you. This program is really attractive and interesting for the industry, of course. Okay, so if we have no more question, I will thank you again, Robert, and I will thank all the participants of this today product quiz and all our speakers. Thank you very much for this interesting presentation. And yeah, you have the poll now if you want to answer, and I tell you, see you next time for another epic event. Thank you very much. Goodbye.
Thank you very much.
Goodbye. Thank you.